Hi, this video we're going to look at the 2D equilibrium, another example. So this is a frame that supports the roof of a small building. The tension in the cable is 150, so that's the tension in this BDF, right? Okay, then determine the reaction at the fixed end A. Well, when we have a frame problem, you realize there are several structures. You have ABC, and you have DCE, and then you have this pulley and have a rope BDF. So you have a choice to either look at them individually or you are going to look at them as a whole. If you look at them individually, you have to look at the force in between those members. However, if you look at them as a whole, then the forces in between those members become internal force. We don't worry about it. Just like if you have a table here, and between the tabletop and the leg, there may be nails or glues that's put them together. However, when you look at this as a whole on the surface, on the ground, we don't consider the FBD. We only have the weight and the normal force that's acting on it. We don't worry about those details, the internal structure, because it's no longer related. Well, look at this entire FBD. Those internal structure, internal forces is not exposed. We only need to worry about what force is acting on this whole thing, which is for this situation would be just weight and a normal force. So this is the same concept here. There will be time when in our frames you're gonna look at dismember them, look at each individual member. But for this, we are going to look at this entire structure, which is A, B, C, D, C, and B, D, F, all those together. Okay, that's our goal. So if we're looking at them together, we're going to draw our FBD. Is all the forces acting on this whole thing together. If we're acting on this whole thing together, I don't worry about the forces at C, right? I don't worry about force at D. And if I'm going to look at this entire thing, all I forces I have is just 4 forces acting on here, 20 Newton each, and at E, because this structure is in contact with external surrounding at E. And E is a fixed support. Fixed support will have EX and EY. We'll also have a moment, right? And if we assume this moment is going this direction, that's going to be we call moment at E. Those are the 3 of unknown due to the fixed support. Because it cannot move, it cannot rotate, so we have EX, EY, and ME. Any other forces acting on this entire structure? Some of you might argue is going to be point B. I said that I would say no. Why so? Because this is the entire structure. So A, B, C, and BD is connected, so B is internal. That's not going to be any forces on there. However, this entire structure is in contact here at F, and here, that's going to be our tension in the same direction of the F line. And that tension is going to be 150 kilonewton. That's given. Now we have our FBD. Then we can go ahead and solve those reactions at a fixed end E. 3 unknowns. We have 3 equations. So let's go ahead write down our Fx equation. What forces do we have at x direction? None of those 20 kilonewton, but we do have Ex. It's perfectly to the right, so it's positive. And we have this tension. Tension have x component. So if we decompose this, we'll be here, right? Tx and ty. We didn't give an angle, however, we give our geometry. We can just go ahead and use that. Since this is the same line as this line, so let's think about add those together. That's going to give us 6 meters. And this is 4.5. So this, what that tells us, this is 4.5. I'm sorry. This is 6, and this is 4.5. Let's simplify that. What is 6 and 4.5? Divide by 1.5, that's become 3. That become 4. Voila! Is that neat? That's basically, it's what? 3, 4, 5 triangle. So basically, that really is our 4. It's 3, 4, 5 triangle. I'm going to go right down there. 4, 3, 5. So 3, 4, 5 triangle. Then we can simply just decompose to x direction. That's where we are now. Forces at x direction. So we're at 150. The x component will be this horizontal 3/5, and it's to the right, right? This force is to the right, so it's plus. That equals 0. Now let's look at forces at a y direction. What forces do we have at y? Many. There are how many? 20. There are 4 20. They're all going downward. So negative 4 times 20. Then we have this reaction support at E. Y, positive, going upward. RFBD. Then with this T, tension 150. And the Y component will be 4/5. However, that one is going downward, so it's going to be negative. That equals 0. Right? Then the last equation is going to be our moment equation. Moment, you choose a point to have a lot of forces on it. Obviously, will be our E. Point E right here. Now let's take a look. Point at E. All the forces going to rotating about E. We're going to consider incorporating this equation. So this equation going to be long. I anticipate this being so long, so I'm going to actually move to very left. Okay. So first is this 20 kilonewton at A. So this is 20 rotating about E. The moment of arm will be 4 of the 1.8. And that rotation is counterclockwise, so that's positive. Then the next one is this 20 kilonewton. So this 20 kilonewton, the moment of arm is 1.8 times 3. And that's also counterclockwise, so that's positive. Then move to the next. We have this 20 kilonewton times 1.8 times 2. Then the very last one is this 20 kilonewton times 1.8, then plus. All right, so we got all those 20 kilonewton taken care of. Now we move to EX and EY. And we know EX rotating about E is 0, same as EY rotating about E is 0 because it's going through point E. However, there's one very important thing. This ME is going to be in your equation. This is a fixed support. E is a fixed support. This ME is produced because this is a fixed support, and this ME has nothing to do with this ME right here. This is the moment equation. We'll consider all the forces and all the moment in this moment equilibrium equation. However, this ME is what you are solving. It's part of the reactions. Okay. And this ME, since we draw already counterclockwise in our FBD, we assume that's the direction, so that's going to be positive. Okay, counterclockwise as positive. Now we finish everything going on at the point E, those forces and the moment EX, EY, and ME. Again, I want to focus on that's important. Don't forget ME in your sum of the moment at E. Okay, so the last one is going to be your T, right? You have a TX and you have a TY. Then, did you notice TX going through point E? So that should not be in the equation. Then the last one will be just TY rotating about E. Do we know TY already? TY is 150 times 4/5. That's the force. And what's the moment of arm for TY? If we would draw, moment of arm would be from here to here, right? That's perpendicular, and that times 4.5. And that rotation, this force is rotating about E, that's clockwise rotation. So this is going to be negative. All of that equals 0. So again, using linear equation, you can solve your EX, EY, and ME. Okay. So I suggest you to go ahead and find out the answer using your calculator or linear equations using online like Wolfram Alpha. All right, that's all. See you next time. Bye.